Welcome back. In this section, we'll be talking about word problems. And so we'll be looking at some story kinds of problems where we've got information given to us and we need to solve for something. So for us, usually the biggest problem with these sorts of questions is how do we take the information and put it together into some sort of an equation? So one of the best things that we might consider doing is maybe taking the information that we have and summarizing it maybe in a table of values. Maybe if it's something that involves something geometric, we might want to do some drawing as well. So we'll talk also about some strategies for solving word problems. With this first word problem, we've got a chemist who's got 2 liters of a solution that's 10% sulfuric acid, and then we've got a second solution that's 20% sulfuric acid, and we want to know how many liters of that second solution do we need so that when we mix them together, we get a solution where there's exactly 1 liter of sulfuric acid. So lots of information in this one problem. And so I think one of the first things we might want to do is just sort of organize all of the information, think about what we have, think about what we're looking for, think about what we don't know, and then we'll start to talk about introducing variables and all the rest. So first things first, I've got 2 different solutions. I've got this 10% solution, and I've got this 20% solution. And as far as the solutions go, there's 2 different quantities. There's how much of the solution do we have? And that's being measured in liters. And then we also have a second thing, which is how much acid is in that solution. So there's the amount of solution that we have, and there's also the amount of acid that we've got. And that's also being measured in liters. So if I wanted to organize my information, I'd say, well, I could put it into a little table like this, where I've got 2 rows and 2 columns. I have information about the 10% solution in my first column, and I've got information about the 20% solution in my second column. I know everything already about the 10% solution. I know that I've got 2 liters of it, so if I wanted to say how much solution is there, it's 2 liters. And I also know how much of that solution is acid. Since it's a 10% solution, then I would expect 10% of 2 liters, or in other words, there should be 0.2 liters worth of acid in those 2 liters of 10% solution. The second thing that we've got is the 20% solution, and we don't know a lot about it. We don't know how many liters do we have, and we also don't know how much of that needs to be acid. So this is where we might think about starting to set up a variable. I might say to myself, well, I'm looking at this, and I don't know how many liters of solution do I have, so I might start off by saying that I'm going to let x be the number of liters of the 20% solution. So now I can go back and in my little table, I can say that for the 20% solution, I've got X liters of it. And kind of in the same way that we did before, if it was 2 liters of solution and it was a 10% solution, the amount of acid we had was 10% times those 2 liters. Same sort of an idea here. We've got our mystery unknown X liters of our 20% solution. So how much is acid? Well, whatever 20% of X is, or in other words, 0.2X. So we've organized all of our information, and now we need to look at what are we actually looking to find. It says how many liters of a solution do we need so that we have a solution that contains exactly 1 liter of sulfuric acid. So in other words, we're saying that if we took all of the acid amounts that we have together, the 0.2 liters from that 10% solution and the 0.2x from our 20% solution, it needs to combine together to give you exactly 1 liter. That's actually telling us our first equation that we would create for the day, which is if we take the amount of acid from that first solution plus the amount of acid from the second solution, then together it should add up to 1 liter of acid in total. So now we've created our equation, and this is our creation that needs to be solved. So now what I'll do, I'll just solve it like I would any other equation, bringing the 0.2 to the other side. 0.8 divided by 0.2 is 4. So I now have x equals 4. So in other words, it looks like I need 4 liters of that 20% solution. Whenever we're doing a word problem, the last thing that we should be doing is going back to make sure that we actually have solved the question, that there isn't any extra information we're also being looking to find, and then finally summarize our answer with some sort of a little sentence at the end. So just going back, all we're looking to find is how many liters of the solution do we need, and we just found that out. That answer is 4. So I will say for my conclusion, I need 4 liters of the 20% solution. And there we go. I would now say that that problem is nicely solved. Okay, let's do another one here. This one, we've got a rectangular sheet of paper. We've got the length is 3 centimeters larger than the width, and then we've got the total perimeter being 74 centimeters. And it looks like there's 2 things we're looking for here. Number 1, what are the dimensions? So what is the length and width? And then after that, we're looking for what is the area of this sheet of paper. So we need to remember that when we're giving our answer, we've actually got 2 things to tell the reader. So first things first, this is something geometric, so maybe it would be nice to draw ourselves a picture. So here's my sheet of paper, my rectangular sheet of paper, and I don't know what the length is, and I don't know what the width is. I know there's a relationship between the length and the width. It says the length is 3 centimeters larger than the width, but I don't know what the width is, so maybe I might want to start off by saying let x be the width of the paper, and that's being measured in centimeters. So in my little drawing here, I can have my width being x and x. And here it also says that the length is 3 centimeters larger than the width. So whatever the width is, add 3 onto it, and that would give you the length. So that means the lengths are x plus 3 and x plus 3. Okay, so we've used all of our information in our drawing. I've got my lengths being x plus 3, and I've got my widths being x. And then finally, I've got this second sentence that says the total perimeter is 74. So if we remember what perimeter is the distance around the outside. So if we said, what's the perimeter of this sheet of paper? It's our width plus our length plus our width plus our length. So in other words, I know my perimeter, which is 74, should be x plus an x plus 3 plus another x plus another x plus 3. It's all 4 sides all added together. And there we go. There's our equation that we need to solve. We have 74 is equal to, we've got 4 x's, and 3 plus 3, we've got 6. So away we go. We can now say that we've got 68 equals 4x, or that x is 17. So this is a spot where, again, I want to remind us that when we're solving a word problem, we need to go back and make sure that we know that we've solved and found everything that we need to find. So if we just stopped right here and said the width is 17 centimeters, we actually haven't answered the question, because the question wants us to answer what are the dimensions. So I need to know not just the width, but also what is the length. And I also need to find out what the area is. So stopping here with the width is 17 is not enough. I need to go one step further and say, well, what's the length as well? And so I also know then, since the length is 3 centimeters more than the width, then if x is 17, if width is 17, then the length is 17 plus 3, which is 20. So first things first, the dimensions are 17 centimeters by 20 centimeters. And then finally, the other thing that we were asked to find was the area of the sheet of paper. And we know for area, area is length times width. So if I wanted to find the area, I would say to myself, area is length times width, or 17 times 20, which is 340. So my second conclusion that I would have to give is the area is 340 centimeters squared. And so now, going back and making sure that we've done everything we need to do, we answered the question, what are the dimensions of the sheet of paper? There we are. The dimensions are 17 centimeters by 20 centimeters. And then the other thing we needed to answer was, what was the area of the sheet of paper? And we found the area. It was 340 centimeters squared. Also, you'll notice that when I gave my answer in a sentence form, I used proper units. So I didn't just say the dimensions were 17 by 20. I said 17 centimeters by 20 centimeters. And same thing with the area. I didn't just say the area was 340. I said it was 340 centimeters squared.